A very warm greetings to all my dear students. In this video, we are going to solve a problem based on linear filtering method. Okay. First, we'll try to solve the problem using DFT method, and then we'll solve the problem using circular convolution method. Okay. We'll see what is given in a question. Determine the response of FAR filter with the impulse response h of n is equal to 1 to 3 and the input signal x of n is equal to 1 to 2 1. So here you have to find out the response which is y of n. Okay. So h of n is given and x of n input signal is also given. Okay. So this arrow indicates the sequence starts from here. This is your h of 0, h of 1, h of 2. This is x of 0, x of 1, x of 2, x of 3. So already we have discussed the procedure for solving this problem using DFT method. Yes. First you have to perform DFT for the input signal in order to find out x of k. Second, you have to perform DFT for the impulse response in order to find out h of k, and you have to multiply both in order to get your y of k value. After that, you have to find out the response of this signal by performing IDFT for y of k. Okay. So this is your procedure, and you have to find out the length. What is your length? N is equal to L plus M minus 1. Here L is the length of input signal 1, 2, 3, 4. M is the length of impulse response 1, 2, 3. So 4 plus 3 minus 1 gives you 6. So N is equal to 6. In order to perform the DFT, we are assuming N as 8. Okay. And N and K varies from 0 to 7. Okay. The limit is from 0 to n minus 1. So here n minus 1 is 8 minus 1. So we are considering the values of n and k from 0 to 7. Okay. So now your DFT formula is x of k is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi nk divided by n. Here your limit is 0 to n minus 1. X of k is equal to summation n equal to 0 to 7 x of n e power minus j 2 pi nk divided by your n value is 8. We are assuming to be 8. Okay. So we are expanding this summation x of 0 into e power 0 plus x of 1 into e power minus j 2 pi k divided by 8. If you simplify, you will get pi k divided by 4 plus x of 2 e power minus j 2 pi k into 2 divided by 8. If you simplify, you will be getting pi k divided by 2 plus x of 3 e power minus j 2 pi k into 3 divided by 8 plus x of 4 e power minus j 2 pi k into 4 divided by 8 plus x of 5 into e power minus j 2 pi k into 5 divided by 8 plus x of 6 into e power minus j 2 pi k into 6 divided by 8 plus x of 7 into e power minus j 2 pi k into 7 divided by 8. So we have substituted the n values and expanded this term. Now what is given in your question? X of n is equal to 1 to 2 1. So the sequence starts from here. It is x of 0, x of 1, x of 2, x of 3. So we can substitute only till x of 3. The remaining values will be 0. Okay. So consider from x of 0 to x of 3. Okay. So x of k is equal to 1 plus, what is x of 0? It is 1. 1 plus 2 into e power minus j pi k divided by 4 plus x of 2 is 2. 2 into e power minus j pi k divided by 2 plus x of 3 is 1 into e power minus j 3 pi k divided by 4. So this is your x of k value. From this equation, you are going to substitute the values of k from 0 to 7. So here I have substituted the values of k and found out the equation for this term. Okay. Next you have to find out h of k by performing DFT for h of n, right? So the given impulse response is h of n is equal to 1, 2, 3. The sequence starts from here, h of 0, h of 1, h of 2. So your DFT formula for finding out the value of h of k is equal to summation n equal to 0 to 7 h of n e power minus j 2 pi n k divided by 8. So here we have h of 0, h of 1, h of 2. That's why I have substituted the n value for h of 0, h of 1 and h of 2. The remaining will be 0. So here I am substituting k as 0. I am getting 6. So for k is equal to 1, this answer. For k is equal to 2, I will be getting this one. For k is equal to 3. And when we substitute k is equal to 4, your answer is 2. When you substitute k is equal to 5, getting this one. When k is equal to 6, minus 2 plus j2. When k is equal to 7, I am getting this one. After finding out h of k sequence and x of k sequence, what you are going to do? We have to multiply in order to find out the answer for y of k. Then only we can able to reconstruct the response from y of k sequence. Okay. So we have performed DFT in order to find out the value of x of k and h of k. The next step is you have to multiply the x of k and h of k values in order to get y of k sequence. Okay. So now I am doing that. Y of 0 is equal to x of 0 into h of 0. We have already found the values of x of k and h of k. You are going to substitute it here and you are going to multiply in order to get the value of y of 0. Okay. It is 6 into 6, 36. X of 0 value is 6. H of 0 value is also 6. So your y of 0 value will be 36. Same way, you are going to substitute x of 1 value and h of 1 value, and I am getting minus 14.07 minus j 17.48. Okay, I am substituting y of 2 is equal to x of 2 into h of 2 and I am getting j4. For y of 3, I am substituting x of 3 into h of 3, I am getting 0.07 plus j 0.515. For y of 4, your x of 4 value is 0, so I am getting 0. For y of 5, x of 5 into h of 5 gives you 0.07 minus j 0.515. For y of 6, I am substituting x of 6 into h of 6, I am getting minus j4. For y of 7 is equal to x of 7 into h of 7 and I am getting minus 14.07 plus j 17.48. Okay. So now we have found the equation sequence for y of k. Now the next step is you are going to find out the response for y of n by performing IDFT for y of k. So we know the IDFT formula, right? Inverse Fourier discrete Fourier transform formula is y of n is equal to 1 by n summation k equal to 0 to n minus 1 y of k into e power j 2 pi n k divided by n. Here n value is 8. We have assumed to be 8. So 1 by 8, it is common for the expansion y of 0 into e power 0 plus y of 1 into e power j 2 pi n divided by 8 plus y of 2 into e power j 2 pi n 2 divided by 8 plus y of 3 e power j 2 pi n 3 divided by 8 plus y of 4 into e power j 2 pi n into 4 divided by 8 plus y of 5 into e power j 2 pi n into 5 divided by 8 plus y of 6 e power j 2 pi n into 6 divided by 8 plus y of 7 into e power j 2 pi n into 7 divided by 8. Now I have substituted the k values which varies from 0 to 7 and I have expanded the term. Now I am going to substitute the n values in order to find out the response of the sequence. Okay, when I substitute n as 0, I I am getting 1. When I substitute n is equal to 1, your y of 1 will be 4. When n is equal to 2, your y of 2 is equal to 9. When n is equal to 3, y of 3 is equal to 11. When n is equal to 4, y of 4 is equal to 8. When n is equal to 5, y of 5 is equal to 3. When n is equal to 6, y of 6 is equal to 0. When n is equal to 7, y of 7 is equal to 0. So what is given in your question? You have to find out the response of FER filter, which is nothing but your output signal, y of n. Now we have found the output signal. Y of n is equal to 1, 4, 9, 11, 8, 3, 0, 0. Now do you remember what is the length? N is equal to 6. But we have assumed in order to perform DFT and IDFT n as 8. Okay? But exact n value is 6. By looking into this equation, see, last two expression is 0. So we can discard this one. So the actual sequence length is 6. So y of n is equal to 1, 4, 9, 11, 8, 3. This is your response of the FER filter. So this is the first method, linear filtering using DFT. Okay. So we will solve the linear filtering using circular convolution method. Okay. So here we are going to solve the same problem using circular convolution method. Okay. In order to find out the response of FER filter, which is y of n, we are going to use circular convolution method, matrix format. Okay. So we'll see what happens. Y of n is equal to x of n, which is convoluted with h of n. Here, what is your length? N is equal to L plus M minus 1, which is 6. In order to make the length of input signal and impulse signal, which is equal to n, we are adding zeros at the end. Okay. Your length of x of n is 4. 1, 2, 3, 4. So, we are adding 2 zeros at the end of the sequence. Same way, the length of impulse response is 3. 1, 2, 3. We are adding 3 zeros at the end of the sequence. Okay, we will perform the matrix format of the circular convolution. Y of n is equal to 1, 2, 2, 1, 0, 0. So we have to write the last point at the first. 0, 1, 2, 2, 1, 0. Again last at the first. 0, 0, 1, 2, 2, 1. We have to perform until we get the first element at the end. Okay. This is your x of n matrix. Next, just write the h of n matrix like this, and you are going to perform row wise and into column wise. So when you multiply 1 into 1, it is 1, 0 into 0, 0, 0 into 0, 0, the remaining 3 terms will be 0. For the second sequence, 2 into 1, 2, 1 into 2 plus 2, plus here we have 0 and here also we have 0, the rest of the elements will be 0. For the third sequence, 2 into 1, 2, plus 2 into 2, 4, plus 1 into 3, 3, the rest of the elements will be 0. For the fourth sequence, 1 into 1, 1, 2 into 2, 4, 2 into 3, 6, and the rest of the elements will be 0. For the fifth sequence, it is 0, plus 1 into 2, 2, plus 2 into 3, 6, plus the rest of the elements will be 0. For the next sequence, first two elements 0 and third one 1 into 3 gives you 3 and the rest of the elements 0. So your answer is 1, 2 plus 2, 4, 2 plus 4 plus 3, 9, 1 plus 4 plus 6, 11, 2 plus 6, 8 and 3. So this is your Y of n. 1, 4, 9, 11, 8, 3. The same answer we have got using DFT method also. Okay. So these are the two methods, using DFT and using circular convolution for the linear filtering method. I hope you have gotten clear idea about how to solve the linear filtering using DFT method and circular convolution method. Yes, thank you. See you in the next video.